Welcome to Math 104, Section 4.5, Multiplication of Monomials. So we're going to put our properties of exponents to work, because nearly every operation we do in this section involves those properties. We're going to start by multiplying monomials, because that's going to be the base operation throughout this lesson. So multiplying monomials, we have expressions with just one term in them. So what we're going to do is multiply numbers by numbers, and then variables by variables as long as we have a common base. Remember, we can only combine variable expressions that have the same base using the properties of exponents. So in this case, we got 3 times 2 gives us 6. And we do x to the 4th times x to the 5th. Recall that when we multiply exponentials with the same base, we add the exponents. That gives us x to the 9th power. 6x to the 9th. Your turn, number 1. So in this one we've got some negatives. So the first thing I do when I'm multiplying is I take care of the signs. That way I don't forget. I see a lot of students will go ahead and do the entire problem and then forget about the signs at the end. So a nice way to avoid that mistake is to just do the signs right at the beginning. So you got a negative times a positive, that's going to give us a negative answer. Now we do the number 2 times 4, it's 8. And then x to the negative 3 times x to the 7th. Remember, negative exponents work the exact same way as positive exponents. So we're going to add those two together. Negative 3 plus 7 is 4, so x to the 4th. Negative 8, x to the 4th power. Now there may be any number of variables inside these, and there could be any number of expressions. So the next example, we've got negative 5, x squared y is equal to 5. All right, we're going to have 2 or 3 variables in each of these. So I'm going to do the same procedure. I'm going to start with the signs. Negative, got no negative here. We've got negative here. Negative times negative is a positive, so negatives cancel. So our answer will be positive. Now we got 5 times 3 times 1, that's 15. Now we'll combine the x's, and only the x's. X squared times x to the 4th times x to the 1st power. If we add up all 3 of those, we got 2 plus 4 plus 1 is 7, so x to the 7th power. All right, now we'll do the y's separately. Do each variable separately. Y times y to the negative 3 times y to the 7th. That's y to the 5th. 1 plus negative 3 plus 7. Now we'll do the z's. Okay, there's only one z, so there's nothing to combine it with, so that just comes down in the answer. 15, x to the 7th, y to the 5th, z to the 5th. Your turn, number 2. So multiplying these out, we've got 2 negatives, so again those will cancel. All right, then we've got 1 coefficient here, times 4 times 3, so that's 12. Now we'll do the x's. X to the negative 3 times x to the 3rd. Add those together, we get 0, and then got 1 more here, so a single x in the answer. Now we'll do the y's. Got 2 of them here, and that's it, so y squared. All right, we have z to the negative 1, z to 3, z to 4. So add all those stuff. 7 minus 1 is 6. Z to the 6th. 12xy squared z to the 6th. All right, now we're going to multiply monomials by polynomials. So in essence, what we're going to be doing is operations like this repeatedly. So we got negative 3 times negative 2x squared plus 4x. All right, so we have 2 terms inside the parentheses we need to distribute, so we're doing 2 separate monomial by monomial multiplications. All right, negative 3 times negative 2 is positive 6. Then we keep the variable part, x squared. All right, now we'll do the second term. Negative 3 times negative 4, or negative 3 times positive 4 is negative 12. And then keep the x. So we get 6x squared minus 12x. Now when you do these, what I recommend doing is going back and doing a quick check. Whenever we multiply or distribute just a number with no variable part inside parentheses, none of the variable parts will change. The variable parts will only change if we have a variable out here. So notice we have x squared here, x here, and x here. Now another check you can do, when you distribute a negative into parentheses, it's going to change the sign of both terms. So we go from negative to positive, positive to negative. So a couple quick checks you can do there to make sure you don't make little mistakes like that. And that brings us to your turn number 3. So we're going to distribute 4 into this polynomial. So 4 times negative 3 is negative 12. Keep the variable part, x to the third, minus 28, or sorry, plus, no, minus, minus 28, x squared. All right, so now we're distributing a positive value in. That means the signs will stay the same. So negative to negative, negative to negative. And then the variable parts stay the same, x to the third, x squared. All right, now we're going to distribute a monomial with a variable part, and that will change the variable parts inside. We've got x to the first power. It's going to raise the power on the x by 1 of everything on the inside. All right, so we got 2 times 1 is 2. X times x is x squared. So we go from x to the first to x squared. Now distribute in here. 2 times 4 is 8. And x. 2x squared plus 8x. Your turn, number 4. Distributing in here, we'll go numbers by numbers. 3 times 5 is 15. X squared times x is x to the third. Minus 27. And we'll keep this variable part, x squared. 15x to the third minus 27x squared. So our polynomials inside the parentheses can have any number of terms, so we're going to do 1 multiplication for each term. So 4 multiplications here. Our negative 4 times 3 is negative 12. X to the 4th times x to the 5th. Add those exponents together to get x to the 9th. All right, next one. Negative 4 times negative 2 is positive 8. X to the 4th times x to the 3rd is x to the 7th. Next one, negative 4 times positive 4 is negative 16. X to the 4th times x is x to the 5th. And finally, negative 4 times negative 8 is positive 32. And x to the 4th, and no variable part here, so we just keep that x to the 4th. All right, so I'm going to do my sign check now. We should be reversing the sign on each one because we're distributing a negative value into the parentheses. So we go positive, negative, negative, positive, positive, negative, negative, positive. So that all checks. And since we're distributing x to the 4th, we should raise all of these powers by 4. So 5 to 9, 3 to 7, 1 to 5, 0 to 4. So that all checks. Your turn, number 5. All right, we're going to distribute in negative 2x to the third power. Negative 2 times 3 is negative 6. X to the third times x to the fourth is x to the 7th. Next up, negative 2 times negative 5 is positive 10. X to the third times x to the third is x to the 6th power. Negative 2 times positive 4 is negative 8. X to the third times x squared is x to the 5th. Negative 2 times negative 8 is positive 16. And x to the third times x is x to the 4th. Negative 2 times 6 is negative 12. And x to the third stays. All right, quick sign check. We're changing every sign, so positive, negative, negative, positive, positive, negative, negative, positive, positive, 2, negative. And now we want to raise all the exponents by 3, so 4 to 7, 3 to 6, 2 to 5, 1 to 4, 0 to 3. So that all checks. Right now we are going to multiply two polynomials together. In essence, we're going to be doing what we just did here, distribution, multiple times. So for example, we got x minus 2 times x squared plus 3x plus 1. Now first of all, how many terms should we get in the answer? All right. Well, what we're going to do is distribute the x into the parentheses. So we'll do 3 multiplications there. And then we're going to distribute negative 2 into the parentheses. So we get 3 more. So we should get 6 terms in our answer. So how do you get that? You take 2 terms here times 3 terms here, you get 6. So 6 terms in the answer. Now we can just go ahead and multiply it out. But some students find it helpful to use a table. So just for this one, I'm going to make the table. And then you can practice doing that once. All right, so we're going to take one binomial and put it here. So we got x and negative 2. We'll put the other binomial here, x squared, 3x, and 1. So now, when we go through and multiply, all we have to do is fill in each block here. Notice we have 6 blocks, like we should. And then we'll just take each column row and match them up with the cell. So x squared times x is x to the third, so that goes here. 3x times x is 3x squared. That goes here. 1 times x is x. 1 times negative 2 is negative 2. Negative 2 times 3x is negative 6x. And negative 2 times x squared is negative 2x squared. All right, so there's all our individual monomial by monomial multiplications. Now all we have to do is go through here and combine like terms. So we got x to the third, that's by itself. We've got a couple of x squared terms here. Add them together and we get x squared. We've got a couple of x terms here. Add them together, we get negative 5x. And then constant by itself. All right, so some people like to use the table. It can be very helpful in keeping things organized. All right, your turn number 6. You can multiply those either with the traditional method or using the table. It's your choice. All right, so I'm going to multiply this one out just using the traditional method. I'm going to take 2x and distribute it into here. So 2x times x squared is 2x to the third. 2x times 5x plus 10x squared. 2x times 6 plus 12x. Now we'll distribute the 3 in. 3 times x squared plus 3x squared. 3 times 5x plus 15x. And 3 times 6 plus 18. All right, now we can combine like terms. 2x to the third is by itself. 10x plus 3x plus 13x squared. 12x plus 15x plus 27x plus 18. So we got 6 terms after multiplication. That's another quick check you need to do. Make sure you're not missing a term. All right, now the next one, a little bit different here. So this one we can do it one of two ways. We can either multiply the binomial times the trinomial first and then distribute in the 2x, or you can distribute the 2x into one of these first and then multiply them out. So I'm going to distribute 2x into here first. So 2x times 3x is 6x squared, and 2x times negative 4 is negative 8x. All right, now we got one just like this. So we'll do 6x squared times x squared, that is 6x to the 4th. 6x squared times negative 5x, negative 30x to the 3rd. 6x squared plus 2 plus 12x squared. Now we'll distribute in the negative 8x. Negative 8x times x squared, that's negative 8x to the 3rd. Negative 8x times negative 5x, that is positive 40x squared. And negative 8x times positive 2 is negative 16x. Now we can combine like terms. 6x to the 4th is by itself, so that will stay as it is. Now I've got negative 30x to the 3rd minus 8x to the 3rd, so minus 38x to the 3rd, and then 12x squared and 40x squared, so that is 52x squared. And finally, you got a 16x by itself there, negative 16x. Right, now this acronym you use called FOIL. You used to hear me say FOIL it. I'll be saying that a lot. So when we FOIL, so when we multiply two binomials together, and this is just a special case of what we're doing here. You can do these exactly the same way we're doing here. Just distribute 2x in and distribute 3 in. And that's basically what FOIL does. FOIL stands for first, outside, inside, and last. So first means the first term in each binomial. So 2x times 5x. So f would be 10x squared. Now the outside are the two outside terms. 2x times negative 8, negative 16x. And then I is for the inside terms, 3 times 5x, and that is 15x. And L is for the last term in each binomial, 3 times negative 8, which is negative 24. And then we can write this out in descending order, 10x squared. Combine these two like terms, so minus x minus 24. Your turn number 7. Use the FOIL method to multiply the binomials. All right, so first, x times x is x squared. Outside, 5 times x, that is 5x. Inside, 2 times x, that is 2x. And last, 2 times 5, so that's 10. So we have x squared. Combine the two like terms in the middle, 7x plus 10. Next up, first, 3x times 2x, that is 6x squared. Last, or outside, 3x times 5, that is 15x. Inside, negative 14x. And last, negative 7 times 5, negative 35. So that gives us 6x squared plus x minus 35. All right, next up, I'd like everybody to take a moment to fill out the table Take the two binomials on the left, FOIL them, get each term, and then simplify it on the right, and then look for patterns and see if you can discover the difference of squares formula. The difference of squares formula will come from the bottom row where we have a plus b times a minus b. Alright, so we're going to FOIL all of these. This one, we got x squared minus x plus x minus 1. This one, we got 4x squared minus 6x plus 6x minus 9. Here, 25x squared minus 20x plus 20x minus 16. And here we got a squared minus ab plus ab minus b squared. Alright, so you may have noticed a pattern developing. The two middle terms are opposites of each other, and those are going to cancel in every one of these cases. So what do we get? Here we get x squared minus 1. Here we get 4x squared minus 9. 25x squared minus 16. And a squared minus b squared. So let's see why that happened. Well, it happens because we have matching binomials except for the signs. The only difference here is the signs. So that means we're going to get, when we do inside and outside, we're going to get the same term but with an opposite sign. That's why they cancel. So this is basically a shortcut way of going from this form to this form. And that's the difference of squares formula. All right, we're going to use this bottom row, a plus b, a minus b equals a squared minus b squared. So this is a really important form in algebra. We're going to be working with this not only in this chapter, but also when we get to the chapter on factoring, we're going to be doing this in reverse. So get to know this form very well. You will need it. So there is the difference of squares formula. All right, now let's do this for the second part. Here we've got the same binomials, but here instead of having the same sign or a different sign, we've got the same sign. So I'll do, I think it did positive version here, so plus, 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 and plus. And then what changes over here? Well, this term changes to plus, 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 everything's plus. Now over here, instead of those two middle terms canceling, we're going to need to add them together. So that first term, that's going to stay exactly the same. We didn't change anything in the first term in each binomial. But now we've got x plus x here, so it's x squared plus 2x plus 1. And here we got 6x plus 6x, that's 12x, so we got plus 12x plus 9. We got 20 and 20, so plus 40x plus 16. And AB and AB plus 2AB, we got two of those AB terms, plus b squared. All right, so we went from having no middle term, now we've got the double of this term. All right, if I go inside 4 times 5x, I get 20x. Double it to get 40x. 3 times 2x is 6. I can double it to get 12x. X times 1 is x. Double it to get 2x. A times b is ab. Double it to get 2ab. And that's the formula. If we have the same sign, a plus b times a plus b, that gives us a squared plus 2ab plus b squared. And this is another very important formula, and another one that we will be revisiting in Chapter 5 when we do factoring. So make sure you get to know both of these very well. You can always use these as a shortcut. I will never take points off for not showing work if you go from this form to this form, because I expect you to know that. All right, now we're going to multiply some very complex binomials, but we're going to use these formulas to simplify things greatly. And I highly recommend getting to know these formulas well enough so you can recognize these patterns and use these shortcuts. They're really helpful. So we're going to find the product here, and this is going to look kind of crazy in the beginning, but you'll notice that we simplify greatly on the first step. So we got 4x minus 3 plus 2y. And the second one, we got 4x minus 3 minus 2y. Now, if you look at the pattern here, consider this just to be one thing. Pretend this is just an x. Then we got x plus 2y and x minus 2y. Well, that's the difference of squares pattern. But instead of just x, we have 4x minus 3. So I'll have to take that into account. All right, so what we're going to do then is use this difference of squares formula, and we're going to have to identify what a and b are in the formula. All right, a is this binomial 4x minus 3, and b is 2y. So if we use those two facts, then we can just use this formula to write our answer. All right, so we want a squared minus b squared. A was 4x minus 3. So we have 4x minus 3 in parentheses squared. All right, so that's this part, a squared. Now b is 2y, so we're going to subtract 2y squared minus 2y in parentheses squared. All right, so we've gone from this giant mess to something much easier to work with here by using this formula. All right, so that's the utility of knowing this formula. So you can take something nasty like that and just simplify it right down to the formula. All right, so all we have to do now is FOIL this. All right, remember this squared is just 4x minus 3 times 4x minus 3. But if you're getting more sophisticated, notice that this actually works for subtraction as well. We have another version of this formula. So we got a squared minus 2ab plus b squared. All right, here's the subtraction version of the formula. So now if I identify a and b, I can just use this and write it out. Don't even have to FOIL. Or you can FOIL, whichever one you want to do. It really doesn't matter. All right, but if we're going to multiply these out, well, 4x is in the a position, and 3 is in the b position. So what we need is a squared, which is 4x squared, so that's 16x squared, minus 2ab, so that's 2 times 4x times negative 3. So that's negative 24x. And then b squared, that's negative 3 squared, so plus 9. All right, so there's those two followed out. You get the same answer if you just FOIL them. All right, now over here, we're subtracting 2y squared. Square the 2 to get 4. Square the y to get y squared. We can't combine any terms here, no like terms, so that's the answer. All right, that brings us to your turn number 8. And if you're looking for an extra challenge, lots of fractions, go ahead and do your turn number 9. Alright, so same pattern as the example. We got a difference of squares pattern. So that's going to end up being 2x plus 3. We're going to square that. Alright, we're trying to get this form. Alright, 2x plus 3 is the A. 4y is the B. So we want a squared. That's 2x plus 3 squared minus 4y squared. Alright, now FOIL this thing. You get 4x squared plus 12x plus 9 minus 16y squared. Now for number 9, this one's going to get a little complicated. But if you're good at working with fractions, should be no problem. All right, now this time A is 2x over 3 plus 1/2. And B is x over 4. All right, so using this formula, we want a squared. So that's 2x over 3 plus 1/2 squared minus, and B is x over 4, so we got x over 4 squared. All right, now we're going to FOIL this thing. And let's actually go ahead, I'm going to go ahead and write this out because sometimes it can be a lot easier to FOIL it. If you see both binomials, it can actually go through the whole FOIL thing. All right, so square this thing, we get x squared over 16. Just remember to square both the numerator and denominator. All right, over here we got 2x over 3 times 2x over 3. So that is 4x squared over 9. All right, outside, 2x over 3 plus, or times 1/2. Now when we multiply those, we have a 2 in the denominator and a 2 in the numerator. Those two cancel, and that just gives us x over 3. And then when we do this term, we get the same thing, x over 3. 2's cancel. And last, 1/2 times 1/2 is 1/4 minus x squared over 16. All right, so that wasn't too bad. Now we need to combine like terms. Now this you can just do in your calculator, 4/9 minus 1/16 to get the coefficient on the x term. Totally fine to do that. I'll just go ahead and do it by hand. I don't have a calculator handy. So we need a common denominator. That common denominator will be 144. And I know that because we have no common factors between the two numbers. This is made up of all 2's, and this is made up of 3's, 3 times 3. So since there's no common factors, the only thing we can do is multiply each fraction by the other's denominator over itself. So that would be 4x squared over 9 times the other denominator, which is 16 over 16. And then we'll subtract 9 times, let's see, we'll do 9 over 9 times x over x squared over 16. Okay. So we're multiplying this one by 16 over 16 and this one by 9 over 9. And that gives us 4 times 16 is 64, x squared over 144 minus 9x squared over 144, and that is 55x squared over 144. All right, so that's that one. 55x squared over 144. And then we combine the x terms, so we get plus 2x over 3, and then 1/4. All right, so that's that one. That one's quite challenging. All right, last topic for today is multiplying polynomial functions. Now we're going back to function notation. Make sure you can answer any question whether it's presented in regular notation or function notation. All right, so we saw properties for addition and subtraction. Here's the property of multiplying functions. So in function notation, we got the combined function f times g of x equals f of x times g of x. So what this means is, it doesn't matter if we evaluate each function separately and then multiply them together, or we can multiply the functions together to get a new function and then plug in the value for x. You get the same answer either way. All right, so example, we got f of x equals x squared minus 9, and g of x equals 2x. Now we want to find f g of x, the combined function f times g. So we're going to multiply these two functions together. So that is going to be x squared minus 9 times 2x. Now before we saw the monomial out in front, it doesn't matter which side it's on, it works the same way. So we'll distribute 2x into here. 2x times x squared is 2x to the third minus 18x. So that is the combined function f times g of x. Your turn, number 10. That's h. All right, now we're going to find f times h of x. So multiply these two together. We're going to FOIL these. Right, first times first. That's x to the third. All right, outside is negative 3x squared. Inside is negative 9x. And outside is plus 27. And no like terms. So there is the combined function f times h of x. All right, next up, we're going to do the same thing. We're going to evaluate at a specific input value. So now we're going to use the same functions as we had in the last two. So we already have the combined function here. Now we want to find f times g at 2. So f times g, evaluated at 2, is going to be 2 times 2 to the third minus 18 times 2, which is 2 to the third is 8 times 2 is 16 minus 36, so we get negative 18. Oh, negative 20. Yeah, I can add. Okay, so that brings us to, one more thing I'd like to show you. I said that we get the same answer no matter which way we did it, so I just want to show that real quick. So I'm going to plug that 2 into each of these functions individually. So f of 2 is 2 squared minus 9, which is 4 minus 9, which is negative 5. And g of 2 is 2 times 2, which is 4. Negative. Now we've gotten the two answers individually. Now let's multiply them together, just like this. Negative 5 times 4, negative 20, just like we got doing it the first way. So either way you do it, you get the same answer. All right, your turn, number 11. We're going to use these here and find g times h at negative 2. So plug negative 2 into this. So that gives us, guess what g times h. Oh, there's a misprint. Oh no, it's not exactly the same as 11. Changing on that one. All right, we're doing a new one here. All right, so there's our two functions. Now let's go ahead and plug in -2 into each of these individually. G times -2 equals 2 times -2, which equals -4. And h of -2 equals -2 minus 3, which equals -5. Multiply these together, we should get positive 20. All right, let's find the combined function. GH of x is 2x times x minus 3. All right, multiplying these two functions together, distributing in, that gives us 2x squared minus 6x. All right, now let's find g times h at -2. Plugging into here, you get 2 times -2 squared minus 6 times -2. So that is, -2 squared is 4 times 2 is 8, minus -12, which is 20. So same answers, get if we multiply those two together. All right, that is it for today, everybody. Make sure you practice these considerably. Get these down so they're just automatic. So you'll be using these throughout the remainder of the course.